All right, a 0.063 kilogram chicken egg falls to the ground, and it hits the ground at this speed. It bounces back at a different speed, and we want to get the force on the egg. So let's actually draw this. So we'll have the egg hit the ground at a speed of 20 meters per second, and I'm going to make it downwards negative. It will then bounce back up at a speed of plus 15 meters per second. Let's go ahead and calculate the net force on the egg using the impulse momentum theorem. So F times T equals mv minus mu. Using this idea, F times 0.1, F times 0.1 equals m, which is 0.063, times the bouncing up speed of 15 minus 0.063 times the bouncing speed that it starts off with negative 20, negative because its original speed is, so the speed it hits the ground at is 20, the speed it bounces back at is plus 15. So negative, downwards, upwards, positive. Simplifying this expression, we're going to get 0.1 times F equals, and when we multiply all this out here, we're going to get 2.205. So that gives us a force equal to 22.05 newtons. Excellent. Now, small rockets are used to make tiny adjustments in the speeds of satellites. How long should this rocket produce 30 newtons of thrust to change the velocity of the spacecraft? So again, this is an impulse momentum problem. So we have F times T equals, now I'm going to do a little bit of a shortcut here. I'm going to write this as mv. Let's be strict here. It says we're changing the velocity. A lot of you might write it this way, and I'm fine. I'm going to write it the way I think most students do, and then I'll show you the way a physics teacher would write it. So F times 0.7 equals 6,000. Sorry, let's start again. F times our F is 30 newtons. Our time is what we're solving for. The mass is 6,000, and a lot of you would put 0.7 in for V. And what that will do is that will actually give us a time of 140 seconds. That's totally correct, but I want to be kind of clear on the strict way of doing this. What we should really say is force times time, the impulse, equals mv minus mu, but we're talking about the change in velocity. So what I'm going to do is I'm going to use the distributive property here to actually factor. So v minus u is the change in velocity, and it turns out that that's actually the thing that we are solving for. So 30 times t equals 6,000, and it is v minus u total that equals 0.7. That's actually how I'm going to get this time of 140 seconds. I just wanted to offer you two ways that I would accept for doing this problem. This one, an engineer would look at and be a little skeptical of because they'd want you to use change in velocity. They'd want you to write a little delta sign there like you do when you do rise over run. I'm fine with us sort of going with the units argument and just doing it this way. In your next physics class, you can kind of get in a little bit more detail. All right, now number 9. We have two masses, so we're going to use conservation of momentum. So first, let me just write down m1u1 plus m2u2 equals m1v1 plus m2v2. working with this idea, we're going to say 0.340 is our bullet, so we're going to call that M1. This is M2. And the cart is not moving, so that tells us U2 equals 0. We were also told the potato bounces back at 30, so that tells us V1 is negative 30, whereas the cart V2 rolls forward at positive 2, and U1 is our unknown. I'm just carefully labeling each quantity. So 0.340 U1 plus this 5 kilogram cart not moving. And then what happens next? The bullet recoils back at negative 30, so bounces back means you have a negative sign, plus M2, which is 5 moving at 2 meters per second. All right, simplifying things, 0.340 U1 equals, and let's be careful with this, so 0.340 times 30 plus 10 is giving us negative 0.2. And interestingly enough, I'm getting U1 is actually a negative number. So 2 divided by, 0.2 divided by 0.340, 0.2 divided by 0.340. So I'm getting 0.58 meters per second. Let's just double check our numbers. So we have 0.340 U1, 5 not moving. The potato bounces back at 30. The cart rolls forward at 2. So yes, this is it. I am in fact getting a negative speed for the bullet. So that is very interesting. I borrowed this problem and the numbers are correct, but I think this might actually be a technically wrong problem. Go with these numbers. It's correct, but physically I'm having trouble understanding how this one would make any sense. So that is it for problem number 9. Then for the number 10 problem, what we have is a 5.0 kilogram ball. And this one I'm going to draw out. So we have the ball moving this way, hitting this guy in the chest. So what we have is M1 is 5, and U1 is 8, M2 is 85, and U2 is 0. Then what happens is that they actually travel together. Ow. So M1 is 5, M2 is 85, and V1 equals V2 equals some unknown number. So putting all this together, 5 times, so we'll say M1 V1 plus M2 V2, M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. Putting in our numbers, 5 times 5 times 8 plus 85 times 0 equals 5 times v plus 85 times v, since they're going at the same final speed. So 40 equals 90 v, so v equals 0.44 meters per second. I'm just going to clean this up just a little bit so it's more legible, so that's 0.44 meters per second. as our final answer. And so that finishes up page 3 of the exam. And I think in our next page we start energy.